6 types of voltage regulators, ICs, integrated circuits, and their functions. Voltage regulators ICs, integrated circuits, are widely used in electronic circuits to maintain a stable output voltage regardless of variations in input voltage or load conditions. There are several types of voltage regulators ICs, each with its own characteristics and applications. Here are some common types. Number 1 is linear voltage regulators are a type of voltage regulator IC that provides a stable output voltage that is regulated to remain constant despite variations in the input voltage or load conditions. They operate by dissipating excess power as heat to maintain the desired output voltage. Linear regulators are simple in design and offer low output noise, making them suitable for applications where precise voltage regulation and low noise are essential. There are 2 main categories of linear voltage regulators. Fixed voltage regulators. Fixed voltage regulators provide a constant output voltage that is predefined by the manufacturer. They are available in various fixed output voltage options such as 5V, 12V, etc. The most common series of fixed voltage regulators are the 78XX series for positive voltage regulators and the 79XX series for negative voltage regulators. For example, the LM7805 provides a fixed output voltage of plus 5 volts, while the LM7912 provides a fixed output voltage of minus 12 volts. Adjustable voltage regulators. Adjustable voltage regulators allow the user to set the output voltage to a desired value within a specified range. They typically require an external voltage divider network to set the output voltage. One of the most popular adjustable linear voltage regulators is the LM317, which can provide output voltages ranging from 1.25 volts to 37 volts. The LM337 is its negative complement. Linear voltage regulators are commonly used in various electronic devices such as power supplies, voltage references, audio equipment, and microcontroller circuits. However, they are less efficient compared to switching regulators, especially when there is a significant difference between the input and output voltages, leading to higher heat dissipation. Therefore, linear regulators are typically chosen for applications where efficiency is not a primary concern, but precise voltage regulation and low output noise are critical. Number 2 is switching voltage regulators, also known as switching regulators or DC-DC converters, are a type of voltage regulator IC that efficiently converts one voltage level to another using switching elements such as transistors, inductors, and capacitors. Unlike linear regulators, which regulate voltage by dissipating excess power as heat, switching regulators operate by rapidly switching the input voltage on and off at high frequencies to control the output voltage. This switching action allows them to achieve higher efficiency compared to linear regulators, especially in applications with a large difference between the input and output voltages. There are several types of switching voltage regulators. Step-down, buck, regulators. Step-down regulators reduce the input voltage to a lower output voltage. They are commonly used in applications where the input voltage is higher than the required output voltage, such as in battery-powered devices, LED drivers, and automotive electronics. Step-up, boost, regulators. Step-up regulators increase the input voltage to a higher output voltage. They are used in applications where the input voltage is lower than the required output voltage, such as in battery chargers, power supplies, and backlighting systems. Buck-boost regulators. Buck-boost regulators can step up or step down the input voltage to maintain a constant output voltage. They are versatile and suitable for applications where the input voltage can vary widely, such as in portable devices and renewable energy systems. Inverse buck-boost regulators. Inverse buck-boost regulators generate a negative output voltage from a positive input voltage. They are used in applications where a negative voltage rail is required, such as in audio amplifiers and op-amp circuits. Switching voltage regulators offer several advantages over linear regulators, including higher efficiency, smaller size, and lighter weight. However, they may introduce more noise into the output voltage and require more external components for filtering and stabilization. Despite these considerations, switching regulators are widely used in various electronic devices, especially those requiring efficient power conversion and extended battery life. Number 3 is low dropout, LDO. Voltage regulators are a type of linear voltage regulator IC that provides a regulated output voltage while minimizing the dropout voltage, which is the minimum required voltage difference between the input and output for proper regulation. Unlike traditional linear regulators, which typically require a significant voltage difference between the input and output to operate correctly, LDO regulators can maintain regulation even when the input voltage is only slightly higher than the output voltage. Key features of LDO voltage regulators include low dropout voltage. LDO regulators are designed to operate with a minimal dropout voltage, allowing them to regulate the output voltage even when the input voltage is very close to the desired output voltage. This feature makes them suitable for applications where the input voltage is only slightly higher than the required output voltage, such as battery-powered devices. High PSRR, power supply rejection ratio. LDO regulators typically have a high power supply rejection ratio, meaning they can effectively reject variations and noise in the input voltage, providing a stable output voltage even in noisy environments. Low output noise. LDO regulators offer low output noise, making them suitable for applications where noise performance is critical, such as in audio amplifiers and sensitive analog circuits. Simple design. LDO regulators have a simple design compared to switching regulators, requiring fewer external components for operation. This simplicity can reduce component count, board space, and overall system cost. Fast transient response. LDO regulators often feature fast transient response characteristics, enabling them to quickly respond to changes in load conditions and maintain stable output voltage regulation. Low quiescent current. Many LDO regulators are designed with low quiescent current consumption, reducing power consumption in standby or low load conditions and extending battery life in portable devices. LDO voltage regulators find applications in a wide range of electronic devices, including battery-powered systems, portable consumer electronics, medical devices, telecommunications equipment, and automotive electronics. They are particularly useful in scenarios where maintaining a stable output voltage with minimal dropout voltage and low noise is crucial. Number 4 is digital voltage regulators are a type of voltage regulator IC that utilize digital control techniques to adjust and regulate the output voltage. Unlike traditional analog voltage regulators, which rely on passive components like resistors, capacitors, and operational amplifiers, digital voltage regulators employ digital signal processing, DSP, and feedback loops to dynamically adjust the output voltage based on various parameters such as load conditions, temperature, and input voltage variations. Key features and characteristics of digital voltage regulators include programmability. Digital voltage regulators offer the ability to program and adjust various parameters such as output voltage, voltage slew rate, and feedback loop characteristics. This programmability provides flexibility in optimizing the regulator's performance for specific applications and operating conditions. High precision. Digital control techniques enable precise voltage regulation and fine-tuning of the output voltage, allowing for tighter voltage tolerances and improved accuracy compared to analog voltage regulators. Adaptive control. Digital voltage regulators can adapt their control algorithms and parameters dynamically in response to changing operating conditions, ensuring optimal performance and efficiency across a wide range of load and input voltage variations. Efficiency. Digital voltage regulators can achieve high efficiency by dynamically adjusting their operating parameters to minimize power dissipation and optimize energy conversion efficiency under varying load conditions. Remote monitoring and control. Digital voltage regulators often include features for remote monitoring and control, such as digital communication interfaces, e.g., I2C, SPI, and telemetry capabilities, allowing for real-time monitoring of operating parameters and remote adjustment of regulator settings. Integration with digital systems. Digital voltage regulators can be easily integrated into digital control systems and microcontroller-based designs, enabling seamless integration with other digital components and peripherals. Fault protection and diagnostics. Digital voltage regulators may include built-in protection features such as overvoltage protection, overcurrent protection, and thermal shutdown, as well as diagnostic capabilities for fault detection and reporting. Digital voltage regulators are commonly used in a wide range of applications, including server and data center power supplies, telecommunications equipment, automotive power management systems, industrial automation, and high-performance computing systems. Their advanced control capabilities, precision, and efficiency make them well-suited for demanding applications where tight regulation, dynamic performance, and energy efficiency are critical requirements. Number 5 is high voltage regulators are a type of voltage regulator IC designed to handle input voltages significantly higher than those typically encountered in low voltage applications. These regulators are specifically engineered to provide a stable and regulated output voltage while ensuring safety and reliability in high voltage environments. Key features and characteristics of high voltage regulators include wide input voltage range. High voltage regulators are designed to operate with input voltages that exceed the capabilities of standard voltage regulators. They can typically handle input voltages ranging from tens to hundreds of volts. High output voltage. These regulators can provide regulated output voltages that may be much higher than the input voltage or a specific reference voltage, depending on the application requirements. Isolation. In many high-voltage applications, isolation between the input and output is essential to ensure safety and protect sensitive circuitry. Some high-voltage regulators incorporate isolation techniques such as transformers or optical couplers to provide galvanic isolation between the input and output. Efficiency. Despite the challenges posed by high input voltages, high-voltage regulators strive to maintain high efficiency levels to minimize power dissipation and maximize energy conversion efficiency. Protection features. High-voltage regulators often include built-in protection features such as overvoltage protection, OVP, overcurrent protection, OCP, thermal shutdown, and reverse polarity protection to safeguard the regulator and connected devices from potential damage. Heat dissipation. Due to the potentially large voltage differentials between the input and output, high-voltage regulators may require effective heat dissipation mechanisms, such as heat sinks or thermal management techniques, to manage the dissipation of excess heat generated during operation. Application-specific designs. High-voltage regulators are tailored to meet the specific requirements of various high-voltage applications, including industrial automation, power distribution, automotive systems, aerospace, medical equipment, and scientific instrumentation. Safety standards compliance. High-voltage regulators intended for use in safety-critical applications must comply with relevant safety standards and regulations to ensure proper insulation, electrical isolation, and protection against electrical hazards. High-voltage regulators play a crucial role in powering and controlling electronic systems and equipment operating in environments with elevated voltage levels. Their robust design, reliability, and adherence to safety standards make them essential components in a wide range of high-voltage applications across diverse industries. Number 6 is negative voltage regulators are a type of voltage regulator IC that generate a stable, regulated output voltage that is lower than the input voltage, but with a negative polarity. These regulators are specifically designed to produce negative output voltages, which are required in many electronic circuits and systems where both positive and negative supply voltages are necessary. Key features and characteristics of negative voltage regulators include output voltage polarity. Negative voltage regulators provide output voltages with negative polarity relative to the common ground or reference potential. This negative voltage is essential for powering components such as operational amplifiers, analog-to-digital converters, and other circuitry that require both positive and negative supply voltages. Fixed or adjustable output. Similar to positive voltage regulators, negative voltage regulators are available in both fixed and adjustable configurations. Fixed negative voltage regulators provide a predefined output voltage level, e.g., -5V, -12V, while adjustable regulators allow for fine-tuning of the output voltage within a specified range. Load regulation. Negative voltage regulators maintain a stable output voltage even in the presence of varying loads, ensuring consistent performance across different operating conditions. Line regulation. These regulators also exhibit good line regulation, meaning they can maintain a constant output voltage despite fluctuations in the input voltage. Efficiency. While negative voltage regulators may not be as efficient as their positive counterparts, they still offer relatively high efficiency in converting the input voltage to the regulated negative output voltage. Protection features. Negative voltage regulators may incorporate protection features such as overcurrent protection, OCP, thermal shutdown, and reverse polarity protection to safeguard the regulator and connected devices from damage due to fault conditions. Applications. Negative voltage regulators find applications in various electronic systems and devices, including audio amplifiers, analog signal processing circuits, test and measurement equipment, telecommunication systems, and laboratory instrumentation. Integration. Some negative voltage regulators are available as part of integrated voltage regulator ICs, which may include additional features such as multiple outputs, on-chip voltage references, and adjustable current limiting. Negative voltage regulators are essential components in electronics design, enabling the provision of stable and regulated negative supply voltages required for the proper operation of many circuits and systems. Their availability in fixed and adjustable configurations, along with their reliability and performance characteristics, make them indispensable in a wide range of applications across different industries. These are some of the common types of voltage regulators ICs. Each type has its own advantages and is suitable for specific applications depending on factors such as input voltage range, output voltage requirements, efficiency, and cost.